So you want to make sure you have your graphing calculator in that permutation mode. So go in the menu right now, option, whatever you need to do, prob, get so that you have the NPR and the factorial, all that stuff. Okay? And what we're asking ourselves today is, hey, what if some of the objects are identical? And we're going to see if we can actually figure out the pattern. We have to tweak our system a little bit. So I have here the number, I wrote out the number of permutations of the 4 different letters A, B, E, and F are, there they are. I listed them all. How many? It's 4 deep by how many across? 6. It's 4 by 6. How many? You could have said it's 4 factorial, but I noticed there's 24 different permutations. Right? Okay, guys? Yes? Now, we're going to see if we can spot a pattern. What I'd like you to do in step 2 is we're going to make 2 of the letters the same. And the way we're going to do that is convert every capital F to a capital E. So in step 2, just add a little line on every single F. That's the easiest way to give you 2 letters the same. It'll take you about 30 seconds. Sean, what I've just done is I've listed the number of permutations of the letters instead of A, B, E, and F, A, B, E, and E, because I made every F and E. How many are there? Well, at first glance, Emma, you might say 24, but look. I think these 2 rows are identical, are they not? And I think these 2 rows are identical, are they not? And I think these 2 rows are identical. So how many are there actually? I think just 12. I think 4, 4, and 4, and don't count the rows that are identical a second time. Can anybody think of a way that I can change a 24 into a 12 based on the fact that 2 letters are the same? Can anybody think of a way that I can take a 24, mathematically change it into a 12 based on the idea that 2 letters are the same? Okay, so my first guess, Jordan, is maybe it's 24 divided by 2 equals 12? I guess that would mean that if 3 letters are the same, if your guess is right, it would be 24 divided by 3, which would be 8. Let's find out. So step 3, now what we're going to do is we're going to change all of the E's and all of the F's into capital B's. In other words, go like this. Make that a B. Oh, that's terrible, Mr. Dueck. Make that a B, make that a B. Make that a B, make that a B. That's why I use these letters, because I could convert them into each other fairly easily. Turn every F and every E into a capital B. Right? You don't need to look up. You can do this on your own. Trust me. Is that okay, Sean? In fact, I think what this is every permutation of the letters A, B, B, and B. 3 B's. How many different permutations are there? Well, now when I look, it seems to me that all 6 of these columns are identical. It looks like each one, the first row is A, B, 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 and each one, the second row is B, A, B, B, and each one, the third row is B, B, A, B, and each one, the fourth row is B, 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 A. You know what? I think that's how many permutations there are of 4 letters when 3 are the same. Not 8. How many? Jordan? 4. Ooh. Can anybody think of a way that I could start with that 24 and get an answer of 4 using a 3? And there's a candy if you can see it. So initially, Jordan suggested this. Except we noticed that the answer isn't 8. What did you say the answer was? 4. Can you tell me how I can somehow write that so that I get 4, not 8? First of all, 24 divided by what is 4? How can I make that bottom look like a 6, or actually be a 6, but only write a 3 there? You might have been right. What did you say? Which actually kind of ties in. Factorial, because isn't 3 factorial? 3 times 2 times 1. As a matter of fact, look up, look up, look up, look up. There should be a factorial there. We didn't notice it, though, because what is 2 factorial? Just plain old? What is 2 times 1? Just plain old? You can't tell the difference between a 2 factorial and a 2, because a 2 factorial is a 2. So we didn't notice it there. Your guess was a reasonable guess, but it turns out we have to divide by factorial. In fact, this is 4 factorial over 2 factorial. From 4 letters, 2 of them repeat. From 4 letters, 3 of them repeat. See the pattern? Candy for you for spotting that a little late. She had the inspiration first. Okay, I'll give you with your little ears. You got little floppy ears. Pardon me? Are you going to give him one? I'll take Erica. Thank you. This is going to be our general pattern. You know what? If you have letters repeating, it's the total number of letters, factorial on the top, divided by how many letters are repeating, factorial. Which actually isn't that difficult in modification. So, let's generalize. Turn the page. If you want to find out how many different ways you can mix up that word there, how many letters grand total? 5? How many repeat? Which is what? Calculator. By the way, what is 2 factorial? Often I don't even put the exclamation mark on a 2 factorial. It's less typing. In fact, for a 3 factorial, I know that's a 6 and it's less typing to type a 6. So often I'll just put a 6 on my calculator, but whatever. What is a 5 factorial divided by 2? Is it 60? Yeah? Okay. B. How many letters grand total? How many repeat? 20, I think, but double check me. By the way, what I did in my head is I said the top is 5 times 4 times 3 times 2 times 1. The bottom is 3 times 2 times 1. I said the 3, 2, and 1 cancel. All that's left is the 5 times 4, 20. You can, if you're lazy, start to do some of the easier ones up here. You don't have to, but I'm a nerd. All right. What about C? How will I calculate that? 5 factorial over? I think that's 5 times 4 times 3 times 2 times 1 divided by 4 times 3 times 2 times 1. I think it's just 5. Check me, but I'm pretty sure it is, yes? Ooh, Mr. Dueck, what happens if you have more than one letter repeating, like in D? Well, how many letters grand total? How many B's? How many C's? Is there more than one factorial, more than one number in the bottom? You better put brackets around the entire bottom. So if you're typing that up, it's going to be 5 factorial divided by open bracket, 2 factorial, close bracket. Oh, I get an error. I got to put a times between them, do I? Okay. Times. I'll be honest. I would have gone 5 factorial divided by 4 because I know that 2 factorial is 2. It's 2 times 2 on the bottom. Did I mention at the beginning of class that the actual arithmetic we're doing here is really not going to be that tough? It's just the procedure. 30? Yeah? So what if I have 3 A's and 2 B's and I want to see how many different ways I can mix those up? How many letters grand total? 5 factorial divided by 3 factorial, 2 factorial. Please practice typing these in because you need to know how to. What do you get? It's going to be 10, is it? Yeah? So here, Caitlin, is our generic rule, and this is, I think, rule 4 on your formula sheet. If you have permutations of n objects where A of them are alike of one kind, and B of them are alike of another kind, and C of them are alike of another kind, etc., 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 the answer is n factorial divided by A factorial, B factorial, C factorial, etc., 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 etc. You good, Erica? Awesome. So, hey, how many permutations are there for the word you're still writing down the definition. Write down the definition. It's the total number of letters factorial divided by however many repeat factorial, however many others repeat factorial, however many others repeat factorial. That's the pattern. That's how I'd write that algebraically. So, Ogopogo. How many letters grand total? 7 factorial divided by how many O's? 4 factorial. How many G's? 2 factorial. How many I already did the O's. How many P's? 1, don't care. How many O's already did? How many G's? Oh, there, I think I covered all the letters. How many different ways are there to mix up the letters? How many permutations are there? How many ways are there to arrange the letters of the word Ogopogo? $105. And I don't need to come up with them and count them because I'd miss one. Statistician. Try this one on your own. Let's see if we get the same thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 2 S's, 3 T's, 2 A's, 3 I's. I think that's it. You notice, Justin, I got lazy. Instead of going 2 factorial, 3 factorial, I went 2 times 6 times 2. I know 2 and 3 factorial because I can do those in my head. 3 factorial is 3 times 2 times 1. 2 factorial is 2 times 1. It's less typing for me. So you could go 2 factorial times 3 factorial times 2 factorial times 3 factorial. Feel free to evaluate the small ones in your head. Is the answer 3,326,400? 33,26,400? Before you turn the page, We're going to have a contest. Let's suppose that you are creating a new email account. And what the email account is going to do is it's going to generate a password. And the way it's going to generate a password is it's going to do a permutation of your full first and last names. Who has the most secure first and last name, and who has the least secure first and last name? So write out your first and last name at the bottom of the page as one word. For me, it's going to be Kelvindueck. And can you please, for a candy, oh yes, my money right now is maybe on Rosanna, but I'm not sure here. So write out your first and last name as one big word. Find out how many permutations there are of it. Go. Now turn the page. Next page. Psst. Shh. Quiet, quiet, quiet. Hello. A true-false test, maybe you've written one, has 7 questions. How many answer keys are possible if 3 answers have to be true and 4 answers have to be false? Well, here is one possible answer key. One possible answer key would look like this. Yes? Hey, isn't that a word? This is why I said we look at words so much. I said if you're kind of clever, you can turn a lot of questions into words. This is actually a word in disguise. How many letters in this word grand total? How many trues? How many falses? How many different answer keys can you make up if 3 of them have to be true and 4 of them have to be false? So you're just scrambling the questions. How many different ways can you scramble or make up this answer key? 35? That's it? Oh, not very many. Another cool application, pathway problems. Example 3. On the following grid, how many different paths can A take to get to B as long as you can only travel east and south, as long as you always have to move closer? You can't double back. Let me give you one such path. The simplest path would be to go east, east, south, 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 south. Yes? And I'm going to say this, Rachel, no matter what order you do things in, how many times are you going to have to go east? Twice. How many times are you going to have to go south? Rachel, are you saying that actually I can turn that pathway question into a word? How many letters in this word? How many times must I go east? How many times must I go south? You want to know how many different ways you can go from A to B, and you can try drawing them if you want to. I would not. $15. Oh, that I could probably draw and count if I was bored. Oh, second one. Here, we're going to treat this like 2 separate pathway questions because although they touch right on the corner there, they don't overlap at all. So here's what I'm going to say. I'm going to have to go east, east, south, south, south. The number of ways I can get from A to the very middle portion where they touch is that many ways. And then here, I have to go south, south, east, east. The number of ways that I can get from the middle to B is By the way, what is the first one? 5 factorial all over 2 factorial, 3 factorial? 10? And what is the second one? 4 factorial divided by 2 factorial, 2 factorial? 6. And now listen close. Listen close. I have 10 choices to go from here to the middle, and 6 choices to go from the middle to B. How many choices do I have altogether? Not 16. What does the fundamental counting principle say that I do when I'm making choices? What do I do with those numbers? I got that many choices to get from A to middle. I got that many choices to get from middle to B. Apparently, 60 paths altogether. Pathway problems. Kind of cool. Some neat applications here. And again, my point, Silke, is with a bit of cleverness, you can turn an awful lot into a word. That's why we start out with words all the time. Turn the page. A few more nasties. Permutations with restrictions. Okay? How many ways can the letters of the word Canada be arranged if the first letter must be N and the last letter must be C? Now we're going to be combining everything. We're going to do the restrictions first. So here's what I have. There's got to be an N there. There's got to be a C there. How many ways do I have to pick an N? How many ways do I have to pick a C? So I've picked the N and I've picked the C. By the way, instead of drawing the Scrabble bag, I'm just crossing off letters because they gave me the actual word in front of me, right? Are there any other restrictions, Sean? Say no. So now I'm going to scramble the remaining word. Now the remaining word has how many letters are not crossed out? Any of them repeat? Yes. 3 A's. I guess the answer to this is going to be 1 times 4 factorial divided by 3 factorial times 1. Am I going to bother multiplying the ones? But I'll put them in case it's not a 1, just so you can, sometimes it won't be. How many different ways can we arrange? How many different words can we make if I have to have an N at the beginning, a C at the end, and I'm allowed to scramble the rest, but I'm not counting the A's all as separate? How many? Go to your calculator. How many? Is it 4? First of all, are you going to bother going 1 times and 1 times? Is that going to change your question at all, multiplying by 1? Rachel? It's going to be 4 factorial divided by 3 factorial.
Oh, I typed the wrong
Oh,
one.
okay.
Don't worry.
So you'll notice, Kyla, when you see the same letter appearing more than once, be much more careful. Example, oranges. Hey, does the word oranges have any letters repeating? No? Okay, this one will be, I think, a little, I'll say easier compared to the other ones. These are still tricky. How many ways can that be arranged? Remember, the word arranged is your trigger word for the fact that it's a permutation. If there's no further restrictions, how many letters are there in the word oranges grand total? 7? So if I'm picking all of them, it's that. Or it's from 7, permutate all 7. Or it's 1, 2, 3, 4, 5, 6, 7 blanks. You got 7 choices, 6 choices, 5 choices, 4 choices, 3 choices, 2 choices, 1. I don't care, Brandon, which approach you use. Clearly one of them, a couple of them are quicker. What is 7 factorial? Or 7 times 6 times 5 times 4? How many ways can I mix up the letters of the word oranges? Is it 5,040? Yeah, okay. What if the first letter has to be an N? Okay. First letter has to be an N. How many ways can I pick an N? Psst. 1. Any other restrictions? So what's left? 6, then? Oh, what's the short way to write 6, then 5, then 4, then 3, then 2? Okay. 6 factorial. It's going to be 1 times 6 factorial. Rachel, am I going to bother actually multiplying by the 1? No. I'll write it, though, so I know I took care of it. 6 factorial, 720? Yeah?